recording and then look at the lab. So with the lab, let me see. Let me check your video very quickly. Okay. Oh, okay. So hold on a second. Yellow, brown. Oh, okay, okay. I see. I see. Let me see if I can find the email from here. There it is. Okay. Okay. So let's see. Yeah, this is the lab from your book. If you have your book with you, you probably recognize it. So yes, essentially, water should not have any change. So, um, let me see if I can pull this up and then have my. Wait, what happened to my iPad? Did I close that? Oh, hold on. Let me pull this up. Okay. So let me have this on the right. Okay. So the goal here is to use chromate ion as an oxidizer, right? So the first one you're doing is you're working with water. And even though water has this formula here, water is not alcohol. Okay? How do you know that oxidation has taken place? When you watch the video, oxidation takes place when the color changes. So the color of chromium, so the part that will change will be the chromate ion, right? So chromate ion right here, chromate changes from yellow to green. Okay? So when it changes to green, you know that oxidation took place. Okay, so hopefully that makes sense, right? Changes from yellow to green, you know oxidation took place. So, yeah. So in other words, if you take the water and you add chromate to it. I'm going to just use a symbol that means the chromate, right? And you oxidize this. What color do we see? We see the color yellow, which means no oxidation, which makes sense. You cannot oxidize this because it's not an alcohol. So that would be right. So you should have, yeah, it's not primary, secondary, or anything. You can draw the water as that. That will make sense. That's fine. But there should be no product here. Number 4 should be Na, nothing. Okay. The next one is ethanol. Ethanol, this one will be CH3. Oh, they have it on there. CH3, CH2OH. So I'm going to redraw this so it looks more like, oh, the answer is on there. Okay. I'm going to redraw it so it looks more like what I was showing you guys, where the C's on the bottom, the O is on the top, the H's are split here, so we can see the H that's about to leave, right? So you can see these two leave, and then what we get here is CH3, C double bond, O, and then H. And this matches what they have, right? And because this actually got oxidized, we see the color green. That means oxidized. Okay? So you're saying in the video 2-propanol showed a blue color? Oh, well, okay. A blue color may be a little bit like a green mixed with something else, right? Because the colors we're really looking for is more like a yellow or green. If something looks like a green or blue, just go with green. Okay? Based on the principle right, based on the principle we understand right now, you're either looking for the color yellow, that means no oxidation, or green oxidation, right? Okay, so the next one here, 2-propanol. Propanol is 3 carbons, right? 1, 2, 3 carbons. On the second one, we have a hydroxide. So it's this carbon here exchanging. Okay, let me write this differently so that I'm going to move the carbon down here because I want my hydrogen on the side. I just prefer it that way. Yeah. So you can see how these two leave, and what we end up with is the carbonyl, and then this comes up here like that. Okay. Yes, this is secondary because you cannot oxidize further. So that should be blue, green, either one works. Okay. And then this one here, let's see. It said 2-methylpropanol. So once again, propan, that means 3 carbons. Okay. 3 carbons, 1, 2, 3. On the second one, we have the alcohol. Oh, sorry. Let me be consistent. On the second one, we have the alcohol, O-H. But on the second one, we also have a methyl, CH3. Ooh, that complicates things. See here? I normally have my H here to be able to oxidize. Yeah, they look correct. I normally have an H here to oxidize, but I don't have H. No matter how I draw it, I need an H here to oxidize. I don't, so there's going to be no oxidation. So it should remain in yellow. Do you have anything in yellow? Yeah, yellow. See that? Your answers make sense. I just think you were just nervous about it. Cyclohexanol. Except for this is cyclo. Cyclo, Elizabeth. Cyclohexanol. So cyclo should be cyclic. That's okay. Don't worry about it. Right, yeah. Right. So cyclohexanol is cyclic, and then OH, right? It makes it different when you're kind of going somewhere and it's kind of dark and you can't see where you're going. Now that you have an idea, right? Hopefully this makes more sense. So cyclohexanol, we're dealing with this. And so if it's just cyclohexanol, that should have changed, because this is the carbon that has the hydrogen, and then you have this one right here. The double bond will form between these two, so you end up with this, right? So this should have been what's the color it changes to? Green. Oh yeah, sorry, my bad. Green. Yeah, they're supposed to be green. So that's good. Green, right? Oh, what happened? Oh no.
We couldn't see the
What
notepad,
happened?
Professor.
It's supposed to be showing my whole screen. So you can't see this? Oh, that's weird. Okay. Yeah, that was weird. I see. Oh, okay, I see. I get what you're saying. Okay, hold on. Corey, the pen. Okay, I think we'll be fine. Wait, how did I get into that? Sorry. I panicked for a second. Okay, this is what you can't see, right? Let me find my email. Okay, there. Right. So it should be green, right? So you take this out here and then you get that that should be green. Okay. So yeah. So your structure should be correct. Looking at this right here, we have no oxidation because this part here is missing. You can see that the H is not there. So that should, yeah, dark yellow, that's fine. Now salicylic acid, I don't have that formula here. Give me just a moment. Let me get the formula. They threw in a salicylic acid? Okay. Okay. Salicylic acid. This is aspirin. Salicylic acid. Misspelled it. Salicylic acid. This is a structure. So it has a benzene ring here. And then there's a OH here. And there's a double bond OH. Okay. So what did you get for that one? Yellow brown, right? So the question is always, do you have an available OH? I mean, sorry, do you have an, because you need an OH next to a CH, right? If you notice all the oxidations here, this was the magic combination that created that, right? In all of these, because the H was missing here, we had no oxidation. With this one, this magic combination created that. Same thing with that. You have to have that combination, an OH next to a CH. So the question we have here is, we have a OH, but do we have a CH? I mean, I see a CH down here. There's a C and there's an H here. Let me remove the name. The next question is, let's try to rearrange this and see if this will work. Because it's all about what's possible, right? I'll write the O here and I'll write the H like that. And I have the C and the H. So the question is, can we remove these two carbons to form this weird, oh no, it won't even work. It won't work. Yeah, I'm trying to look at it saying no, it won't work because the carbon that's is supposed to form a bond with this carbon here. This carbon here doesn't have an H at all. So, long story short, it should remain yellow. That was a long way around to tell you it should remain yellow because this carbon that it should form a bond with does not have a H. The carbon that has an H is too far from it. Plus, it cannot form a bond across like that. So this is not possible. So in other words, this remain yellow can't be oxidized. Okay, so that's pretty much it. Right, right. You should don't feel bad. I overthink too. My friends tell me overthinking the situation. I'm like, no, I think I'm thinking it just right. Do you think? Wait, I'm what? Yeah, that's me. That's fine. But yeah, so that's the whole chapter. So I hope that was helpful, and I hope you can finish your lab now. This is all I have for today. Okay, Brianna, thank you. Thank you all for showing up. Have a nice evening. Okay, thank you. Bye.